Hello guys. In today's video, let us try to understand why validation dataset is basically used. Before that, let us make some assumptions. Let my assumption one say that we live in a planet where 1 second in Earth is equal to 100 years in that planet. Let my assumption two say that creature presents there actually want to build a machine learning model so as to predict the multiples of 1. That is, ideally, they want to predict 1 into A, where A is a data point. Now, let us look into some of the technical words. We all know that one of the thing which we always use is parameter. Parameter is something which we learn during the training. And you may have also heard one more word called hyperparameter. Hyperparameter is something which we actually choose on our own. Now, before diving into what does I mean by usage of validation dataset, it is better to understand what does Google say. Google say that validation dataset is used to tune hyperparameter. Now, it becomes my responsibility to prove this. Now, we all know that machine learning is all about having the dataset and making intelligent predictions out of it. Let's say I have a data set which looks something like this: 1, 1, 2, 2, minus 2, minus 2, minus 3, and 4, 4. Note, 1 multiplied by 1 is 1, 2 multiplied by 1 is 1, minus 3 multiplied by 1 is minus 3, and hence x and y outputs are same here. Now, let us define hyperparameters. Let the number of neurons be 1. I'm keeping it 1 because it's my choice. Now, let the type of activation function which I'm using be ReLU. Now, if you don't know what actually ReLU is, it's not a problem. Let's learn it now. ReLU gives you output of max of 0, comma A, where A is the input and whose output looks something like this. Now, let's say I split my dataset into train and test, which looks something like this. The thing which is in the green box is in train, and the one which is in the pink box goes to the test. In my train data set, I have four data points: 1, 1, 2, 2, minus 2, and 4, 4. Similarly, in test, I have two data points: minus 3, and 5, 5. Let me start now training a model. And in a model, we have something called as input, output, weights, biases. I1 represent input, W1 is weight, B1 is bias, and B is the output. Now, upon training, let's say I get W1 equals 1 and B1 equals 0. As I'm using ReLU as my activation function, the output is max of 0, comma 1. Now, you can see that except for the negative data point, for all the outputs will be correct, and hence the accuracy on my clean data set would be 3/4 of 100, which is equal to 75%. Let's say the time taken for training this model is around 10 years. That is 1/10 of the second if it was done on the Earth. Now, let us test the performance of the model on my testing data set. Now, my test data set contains two data point and one is negative, that will go wrong, and hence the accuracy is 50%. Now, I can see that there is some problem in my model as there is a difference between test accuracy and train accuracy. If I had known it earlier, I would have changed my function from ReLU to something of the form f of x equals x, because this would have trained my model betterly and I would have got better predictions. In this case, it would have given me a prediction of 100%. Now, this is where basically we use validation dataset. Let me consider my test dataset as a validation dataset. Now into the neural networks, we actually pass both train and validation data set, and on the basis of training error, we update the parameters, but we also look into the validation. Let's say now I make a habit of looking into the error versus epoch plot for both train and validation data set. And let's say I see that there is a divergence of both the curve from each other at a point. And let's say I make this observation at the beginning of third month, and hooray, now I actually know I'm not going in the right direction by the end of the third month, and hence I will be able to correct my mistake. I hope that I was able to build an intuition. Basically, we use validation dataset so as to fine tune our hyperparameter. And this is it for the video. Thank you.